Hi, today we'll talk about the landslide susceptibility model. And the landslide is also a problem, and this problem is more associated with the mountainous regions. And in the mountainous regions, also, there are certain factors which affect landslide, maybe the slope, uh, the steepness of the slope, it may be the vegetation cover, it may be the rainfall type, and there may be another geological factors. But since it is related to the Earth's surface, so how we can study with the help of GIS and remote sensing uh, techniques, today we'll discuss in this lecture. Down is something about me. I'm Dr. Zubair Islam, working in the Department of Geography, Adigrad University. More vegetated areas. Inside is the toolbox. Here I will use three parameters to model the land susceptibility. And these three variables are, first is NDVI, which ranges from minus 0.02 to 0.64. The second variable is the slope here, and the next is the rainfall. So we'll use these three parameters. NDVI is like this. Here we can see the NDVI. This is basically a Adigrad town here. The dark red color is showing the settlement area or build-up area of Adigrad town. The next one is the slope here. Slope. So the slope is also okay. Just make it invert. This is the slope here. In the middle, this is the higher side of Adigrad town. The hilly track, which is this is the valley side, okay. And in the middle is the built-up area, the road. And this is here the rainfall. So we'll use these three parameters, okay. So what do you think? How these parameters will help us? If NDVI is high, means vegetation is high. If vegetation is high, landslide will be less. If vegetation is high, okay. Vegetation is low, there it is more suspected that landslide may be there. This is the one parameter. The second is the slope. In the same way, if slope is higher, landslide susceptibility will be higher. And if rainfall is higher, the landslide may be more. So here the rainfall, higher rainfall means landslide more, higher slope landslide more, but NDVI higher, landslide is less. So this we have to keep in our mind, because when we will rescale, reclassify, rescale, then we have to give some weight, and we have to reclassify, and we have to give some, the susceptibility where it may be higher, it may be lower. So let's begin it. We will start modeling here. This is the model, but before we do the model, we make a model, just go to the J processing and environment. The output result, what should be the cell size? It shows the minimum of input. It's fine, okay. Minimum of our input means whatever inputs I am having here, 3, the minimum cell size with whatever cell size, whether it is in NDVI or slope, it will take the minimum. So it is better to take minimum. Why? Because the resolution will be defined. Do it, okay. Now you take your data, NDVI, slope, then this is the rainfall data. Then we will reclassify this one. For reclassification, there is a tool of special under the special analyst toolbox. Then go to the reclass toolset. Then here this is the reclassify, and this tool we need for separate for 3. Okay, this is for rainfall, this is for slope, and here this is for NDVI. We can connect. And we can make auto layout, will be fine. And thereafter we have to reclassify, keeping in the mind that what parameter is doing what. This is the rainfall here, and when we will reclassify the rainfall, it is classified into 9 categories, and you have to see if rainfall is less, means the landslide maybe if rainfall is less, then landslide will be less. Here, if rainfall is high, the landslide will be more. So this 1 to 9 is basically 1 is least suspected and 9 is the highest suspected. So if rainfall is high, 9 is fine here. Okay, so this is what? This is the rainfall. This is the RF reclass. Is it fine? Yeah, here. Apply it. Okay, rainfall RC, maybe I can make it 1 here. Okay, no problem, it will be overwritten. This is the RC. Apply it. Okay, the next is slope. If slope is low, then the landslide will also be the low. If slope is high, it will be higher. So it is also fine. It is at your hand. Okay, you can, when you will classify, you can give more classes also, or you can give less classes also, fine. Here I'm not changing the classes, you can change the method also. So here no need of visualization, you can go to equal interval and thereafter you can reclassify like this also. Okay, so here equal interval is there, 70 to 79. If slope is like this, I'm giving 9. Okay, this is what? This is the slope reclass. Apply it. Okay, and thereafter this is the NDVI. If NDVI is low, then the landslide may be higher. In this case, also better to go for equal classes, because here we do not need to go for appearance. Equal 9. Okay, then if the NDVI is less, vegetation cover is less, what will be the impact? The landslide may be higher, but here it is 1. 1 shows least landslide, so we can reverse the values. Okay, 9 indicates that if vegetation is less, least, higher landslide susceptibility. So I will make it NDVI reclass. Apply, do it. Okay, and after doing all this, I have to take the weighted overlay, and for this, overlay is here, weighted overlay is here. I will reconnect here. Okay. So when you will see this one, and when you will collapse all, it shows 100% influence is going to the rainfall. So for this 0 0, no, in total this should be 100%. You have to give the influence to the slope also and DVI also. So slope, if you are doing 440%, then there is error, because in total it should be 100. So here you can make it 30, and here you can make 40. No, 40, 40, 80, then 30 is 110. Okay, let's make it 30 here. Then it is fine, okay? And this reclassification and giving the values we have already given, we have already done it here. So these are the three parameters I'm using, and there may be more parameters based on your references and studies. And there may be, of course, the soil types, the geology also, the geological structures also, the rock types also. So all these parameters you can input. The method will be the same. Okay, and if there is some type field which you want to restrict in your analysis, then you can restrict also here. When you will go, you can restrict also here, restrict it. So that area will not be included in the analysis part. Fine. So it is done. Apply. Okay. What I need is, I need my result to be displayed at my data view. So for that, what I will do, right click and add to display. And the next thing you can do is, because this is the model, no need to make again and again the model. Maybe once it is run, then maybe you have to modify this model. So better to save it, okay? And when you will save this model here in the Landslide, you should have a box, because under the box only you can save your model. So here I'm writing the Landslide work, and within this Landslide work I can save my model by the Landslide, save it. So this is the LS Landslide, which if I want I can add it also here in my toolbox. This is the Landslide, open. So here I have got this one. If I close it also, then also I can right click and I can edit it. Then you can add more parameters, you can reclassify, and after reclassified image you can add to the overlay weighted. Thereafter you can run and you can recheck it. So add to display is already here, then I will run it. Before I run, you have to observe one thing. Before running, there is no shadow. Once it is run, completed, then the shadow will appear to you. Let's do it, run it. So in the meantime, it is very important that all of your data should be in the same, with the same coordinate system. The coordinate should be same for all the data you are using, like NDVI, slope or rainfall. So this is the result which we have got. And maybe if you are having some road shapefile, then you can see that which road is more vulnerable from the landslide, or the, if you have some infrastructure, another infrastructure, then how you are far from the vulnerability of the landslides. Okay, so of course this area, if you will see that this area of Adigrad town is least vulnerable. That's why the people have constructed their buildings and roads and another infrastructure. But as you will move left and the right side, the vulnerability is high. Means here higher values means what? Higher values means the vulnerability is higher. Higher value means the vulnerability is higher. So you can give some 7 and 8 if you think that 7 and 8 is the my target, that which are the more suspected for the landslide. So if you want to make 7 and 8 out, then you can do it also. Like let's do it spatial analyst, then map algebra, then raster calculator, and here you can make it more than you can say 6, then okay. So you can find the area which is highly suspected for the landslide here. So these are the areas which are highly suspected for the landslides. So as you are moving from Adigra towards Meghalaya, you will find that you have to move down and there is a valley side, and near valley side you will find that there are the steep slopes where the vegetation may also be less here. This area, this side, you see the vegetation is also less here, and when the vegetation is less, slope is higher and rainfall is also more, then this area is highly suspected for the landslide. So this was the simple model for landslide susceptibility. You can increase the variables and you can change some classification. You can change the weightage and you can observe your result, how different it is from your from one analysis to another analysis. So this is enough for this video. We'll meet in the next video. Thanks for watching.